Experiments are a critical component of statistics. Experimental design studies show us the cause and effect relationships between two variables. There are three principles when designing an experiment. It needs to be controlled, it needs to be random, and it needs to be replicated, meaning you are able to perform the experiment and get similar results elsewhere. We started talking about experimental design with the chocolate chip experiment in class, and we will continue that conversation. Still, it is important that you know the vocabulary behind experimental design. So we're going to go through an example while discussing what the vocabulary with experimental design is. Here we go. Suppose we are interested in determining the effect of room temperature on performance on a statistics exam. So we decide to perform an experiment. What variable will we measure? What variable will explain the results? The purpose is to assess the effect of temperature on test score. There are two critical variables when it comes to experimental design: the response variable and the explanatory variables. These two variables are the statistics version of independent variables and dependent variables. A response variable is a variable that is not controlled by the experimenter and that is measured as part of the experiment, while explanatory variables are those variables that have values that are controlled by the experimenter. They are also called factors. We, the experimenter, decide to use two temperature settings, 65 degrees and 75 degrees. Therefore, they are explanatory variables. How many treatments we have is 2. We have 2 treatments. They are the temperature settings. A treatment is any particular combination of the explanatory variables. They're also called experimental conditions. What conditions are you applying to the experiment? Suppose the experimenter has 4 sections of statistics that agree to participate in our study. On who or what will we impose the treatments on? We're going to impose it on the students in the class. How will we determine which sections would be in the rooms with the temperature set at 65 degrees and which sections in rooms set at 75 degrees? Should the teacher decide? Probably not, because there could be some sort of bias there. So how exactly do we decide who is set in which temperature? First, the students would be called subjects. Subjects are the smallest units to which a treatment is applied to. Subjects are all the people or objects that are in a sample. How we would assign these subjects is called random assignment. Random assignment of subjects to treatments or treatments to trials ensures that the experimenter does not systematically favor one treatment over another. So you see, it is important that we don't have the teacher choose because of the potential effects that teacher can have on the experiment. To randomly assign the 4 sections of statistics to the 2 treatment groups, we would first need to number the classes from 1 to 4. Then we place the numbers 1 to 4 on identical slips of paper and put them in a hat. We can mix them well. This is just one way in which we can apply random assignment. We will discuss further ways how to do random assignment, but the important thing is that it is not decided who gets which treatments by the experimenter. Notice that there will be 2 sections assigned to each treatment. How sure will an observer feel if the treatments were tested once? Meaning, how sure are you of the results if you just did this experiment once? What about 5 times? What about 10 times? You're probably more confident in your results if you repeated the treatments with the same subjects multiple times. You feel much better about repeating it 10 times than you would once. This is called replication. Replication is repeating the treatments that were assigned to the same subjects. It ensures that we have multiple observations for each treatment. One thing about statistics is that if you're not able to replicate results, then there might be something uncredible about your experiment. Remember, the explanatory variable is the room temperature setting 65 degrees and 75 degrees. The response variable is the grade on the statistics exam. Excuse me. Are there other variables that could affect the response? There absolutely are. Let's go through some of these. The teacher can have an impact on grades. The location can have an impact. The equipment that a person uses. If a person doesn't have a pencil, then that might affect them. What about a time limit, if there's a time limit? on the test, as well as the clothes you wear since we are testing temperature, or the age of the person. A freshman probably wouldn't do as well as a senior would. What about if they are hungry, if they ate breakfast? There are other variables that could also affect it, such as student ability, the gender of the student, sleep, health, hunger, motivation. The options are pretty endless here. Which variables can we control though? Which variables might be easy to control? Well, all of the variables on the left side here are possible to control. We can assign just one teacher to the stats classes. The location is the same for all the subjects. The equipment, the time. Make sure that people are wearing adequate clothing that is comfortable for them. Make sure that they're close in age, if age is something that we want to consider. And then make sure that they all have the same type of breakfast. This is called direct control. Direct control is holding the extraneous variables constant so that their effects are not confounded with those of the experimental conditions. Meaning, since all the subjects have the same conditions, um, we can't say that those conditions had an impact on the results. But I use this word extraneous variables. What are extraneous variables? An extraneous variable is a variable that is not one of the explanatory variables, but is thought to have the effect on the response, i.e. some of those variables that have effects on grade scores. What about extraneous variables that we cannot control directly or that we don't even think about? There's a plethora of things that we don't even think about when it comes to grades. There could be test anxiety, someone's just having a bad day, or emergencies occur as well. What happens if we can't control some of these things? These lurking variables, extraneous variables that are not incorporated into the design of the experiment and are not directly controlled, do happen in all experiments. It's human nature. We're all unique. We all vary in a lot of different ways. But here's the thing about statistics that is great. Random assignment should evenly spread all extraneous variables that are not controlled directly into all treatment groups. We expect these variables to affect all the experimental groups in the same way. Therefore, their effects are not confounding, which we will discuss later as to how that is implied. So yes, someone might have test anxiety, someone might not be having a bad day, someone may love statistics so much that they will always do well in it. But the fact of the matter is, we are still generalizing the sample, a population from a sample. They're going to represent some sort of aspect of the population. As long as we are not biased in our assignments of the treatments, we can be assured that all of our methods can give us a proper result.